What's up, guys? Today we're going to be looking at the relationship between 2 points in space, as well as the relationship between a point and a line in space. This is going to be the graph we're working with, so just take a quick second and check it over. Okay, so this is our vector PQ. It's going to be equal to the difference of our x components, our y components, and our z components. Let's take a look at point Q. We'll notice that it's made up of x1, y1, and z1, the very same in our vector PQ. And point P is made up of x0, y0, and z0, the very same of our vector PQ. So P is a point at the origin and Q is a point in space. By subtracting the terminal point, or the point in space, by the initial point, the distance between the 2 points can be found. Alright, so using the same graph, we're going to find the magnitude of vector PQ, which is going to be equal to the square root of the difference of our x squared plus the difference of our y squared plus the difference of our z squared. Once we add those together and square root it, it's going to be equal to the magnitude of vector A. The magnitude of vector V will be also equal to a different magnitude. I've just gone ahead and changed it because I think the magnitude of vector A and the magnitude of vector B look better than that and just look simpler overall. So that's the reasoning for that. Let's take a look at vector V. So vector V has terminal point P2 and initial point P, right? So the magnitude of vector V is going to be equal to the square root of the difference of x squared plus the difference in y squared plus the difference in z squared. Let's notice that it's x2 minus x0, different x's, which makes sense because our point 2 has the x point x2, our initial point has the x0. So that's the reasoning for that. Adds up. Alright, so the magnitude of the cross product of vector PQ and vector V is equal to the magnitude of vector A, the magnitude of vector V, sine theta. Let's note once again that the magnitude of A is the magnitude of PQ, and that the magnitude of V is the magnitude of the vector V. So, the magnitude of the cross product of PQ and V over the magnitude of vector B is equal to the magnitude of vector A sine theta. The magnitude of vector A sine theta is equal to the magnitude of PQ sine theta, which is equal to the distance between a line and a point in space. That would be this distance right here.
Hey guys, today we're going to be finding the shortest distance between point Q and a line determined by point P1 and P2. It's a little different than finding the shortest distance between a point and a line segment, so we'll be covering that next. In this case, we have Q at 2, 0, 0, and then a line determined by P1, P2. To find the shortest distance of a point to a line, all you have to do is follow the line down until you find a point perpendicular where Q is perpendicular to the line. And from there you can just use your basic triangle formula, where area is equal to 1/2 the base times the height. Your area is given by the magnitude of QP, by the magnitude of the cross product of QP1 and QP2, and your base will be equal to the magnitude of P1, P2. Using this formula up here, you can move it around so that you can find the height is equal to 2s over b, and h is your shortest distance. So from there, it's just plug it in and run. So plug in your cross product of QP1, QP2, which gets you negative I plus 2j minus 2k. Then find the magnitude, which ends up giving you 3. And find your base, which is the magnitude of P1, P2, which ends up giving you red 2. and then plug these two into that formula up here, which gets you h 2 times 3 over rad 2, which after you simplify gives you 3 rad 2, which would be the shortest distance between your line and your point.
How to find the shortest distance between Q and the line segment determined by the points P1 and P2. First, you must use the distance formula. Then you plug in your numbers. You must simplify the expression under the radical. Then you simplify further to get your answer, which is going to be the square root of 5. So the distance is just the square root of 5.